Okay, so we're going to work through our vector homework here. So our first one up here is A, and we're going to find the components of this vector based off of its magnitude and direction. So first thing we want to do is draw a quick sketch of this vector. I have our north, east, south, west labeled here, and we see that it's 10 meters per second at an angle of 15 degrees south of west. So I'm going to start with my west direction, okay, and I'm going to go 15 degrees south of it. So there's my 15 degrees. So my vector is going to look something like that. I'm now going to draw out my components here. So I'm going to have my x component going that way, my y component going that way. It's important to keep in mind two things. Number one, since this vector is southwest, I'm going to have a west component and a south component. All right, and that's what I do have. The other thing too, as your quick check, is we always want to have those vectors line up tip to tail, which they do, so we're good on our drawing. So this side is going to be the x side, this side is going to be the y side. All right, so in the x side, that is your adjacent side. It's the side touching the angle. So I'm going to skip a little bit here, and I'm just going to say that x is going to be my adjacent side, so it's equal to 10, the hypotenuse, times cosine of the angle. And I'm just going to say that y, my opposite side, is going to be 10 sine of our angle here. All right, and that's always going to be the case. The adjacent side will always be hypotenuse times cosine of the angle, like that, and the opposite side, the side that the angle is looking at, is how I always think of it, will always be hypotenuse times sine of the angle. Be careful, x will not always be cosine. Okay, x could be the opposite side, in which case it would be sine. Similarly, y could be the adjacent side, in which case it would be cosine. So don't get in that habit. But you can make this shortcut here that the adjacent side will always be cosine and the opposite side will always be sine. So if I go ahead and do that math, I find that the x side is going to be equal to 9.66 meters per second. That's my x component, and it is going west. And my y component is going to be 2.59 meters per second, and that is going south. Moving on to my next one here, I have 70 newtons at an angle of 30 degrees north of west. So I'm starting with west, and I'm going to go 30 degrees north. And so my vector is going to look something like that. I draw my components. I'm going to have a west component. I'm going to have a north component. We see that they line up right here, tip to tail. And so this is going to be my x. This is going to be my y. My hypotenuse is at 70 newtons. So when I want to find my x, that is the adjacent side, the side touching the angle. So it's going to be 70 cosine of 30, which gives me an answer of 60.6 newtons. And in the y direction, we're going to have 70 sine of 30, which gives me an answer of 35 newtons. So this one is west, and that x component is 35 newtons north. By the way, newtons is a unit of force. I know we haven't talked a ton about that yet, but that's what newtons would be. Moving on to C, we see that our vector is 18 meters per second squared west, so it would just be a line going directly west, which means that my x component is 18 meters per second squared west, and my y component is simply 0. There is no y component here. Okay, moving on to the next section, we're now given components, and we need to find our vector. So I'm going to start by drawing the components tip to tail, of course. So my first component is this positive 15 meters. So 15 meters east is the positive direction. And then my y component is negative 20. So from the end of that 15 meters, I'm going to draw that 20. Once again, lining it up tip to tail. My resultant vector is going to be the hypotenuse, going from where I started to where I ended. All right. Remember that resultant is showing the overall. So if I started here and ended here, my displacement is from here to here in that southeast direction. Okay. So what I want to do is I want to find the resultant here, that hypotenuse, okay, and I want to find this angle. So, to get the hypotenuse, I'm going to Pythagorize this. Okay, use the Pythagorean theorem. So 15 squared plus 20 squared equals c squared. Okay, and I end up getting an answer here of 25 meters. All right, it actually ends up being a nice Pythagorean triple, so it works out well. And for my angle, I'm going to use trig. So I'm going to say tangent of that angle theta is equal to the opposite side, which would be the 20, the side that the angle is looking at, over the adjacent side, which would be the side that the angle is touching, so over 15. I'm going to take the inverse tangent of both sides, and so on the left side I'm just left with tangent, and on the right side I have inverse tangent of 20 over 15. And so when I go ahead and solve that, I find that my angle, all right, is going to be 53.1 degrees. And I'm going to put a direction on it, okay? So that angle here is measured from the east direction, and we're going south from that east direction. So it's 53.1 degrees south of east. Keep in mind, if you had drawn it the opposite way, if you had done your 20 first and then your 15, and your vector looked like that, that's perfectly acceptable. You would get a different angle though. You would end up getting 36.9 degrees, and then your direction would be east of south instead of south of east. So either answer is acceptable. Moving on to B here, we have an x vector of negative 10 newtons, so 10 newtons to the left, and a y vector of negative 12 newtons, so 12 newtons down. And so my resultant is showing the overall from the beginning to the end. I also have them lined up tip to tail, so we're good to go here. So we're going to solve for our hypotenuse and our angle. So I'm going to start by Pythagorizing it once again. A squared plus b squared equals c squared. So we have 10 squared plus 12 squared equals c squared. So I get a hypotenuse here of 15.6 newtons, okay? The units of the hypotenuse are the same as the units of the components. For the angle, I'm going to say that tangent of that angle equals opposite, which is 12, over the adjacent, which is 10. So the angle is going to be 50.2 degrees, and that is going to be south of west now, and the other option, if you had found the other angle, would be 39.8 degrees west of south. All right, so both of those are acceptable answers. All right, so we're moving on to what we actually want to get done here, and that is vector addition. So we're going to start putting a lot of these ideas together. So we want to add these two vectors here, vector A, 6 meters per second, and vector B, 10 meters per second. So the first thing I'm going to do is do a quick sketch of my two vectors. There's A, there is B, lining them up tip to tail. So my resultant should look something like that red line there. We're going to do it mathematically though. And so when we do it mathematically, the first thing that we're going to do is we are going to componentize our two vectors. We're going to take them and break them into their x and their y components. All right, so we're going to do that mathematically. So I see that my x component is my adjacent side here. So it's going to be 6 cosine 21. My y component is my opposite side. So that's going to be 6 sine 21. All right, moving on to my other vector, the adjacent side is, for my other vector, the y side is now my adjacent, and the x is my opposite. So I'm going to say that x here is 10 sine 29, because sine always goes with the opposite side, and my y is 10 cosine 29. So doing my math, I get that this is going to be equal to 5.6 meters per second. I get that this is going to be equal to 2.15 meters per second. Okay, on the second one for vector B, I get that my x is going to be 4.85 meters per second, and my y component is going to be 8.75 meters per second. I'll deal with my signs in a second, but that right there is step number one, componentizing our vectors. Step number two is we're now going to add up our x and y vectors, and this is where I need to think about my signs. So my overall in the x, I have 5.6, and it's positive because it's going to the right, plus negative 4.85, negative because it's going to the left. In the y, I have 2.15, positive because it's going up, and this one is also positive, the 8.75, because that is also going up. So overall, I get that this resultant is going to be 0.75 meters per second east, because it's a positive number, and 10.9 meters per second north, because that is also a positive number. The final step here now is to draw these two vectors and put them back together. So I'm going to draw my x first. I always draw my x first, although you certainly don't have to. 0.75 meters per second east. And then I'm going to draw my y, 10.9. Like I said, you could have drawn the y first and then the x, but we do need that tip to tail to be true. You got to draw the second vector from the end of the first. So to get the hypotenuse, I'm going to Pythagorize this. A squared plus b squared equals c squared. So 0.75 squared plus 10.9 squared equals c squared. And so I get that my hypotenuse here, the resultant, the magnitude of the resultant, is 10.9 meters per second, 10.92. And for my angle, I'm going to say tangent of theta is opposite, 10.9 over adjacent, 0.75. So my angle is the inverse tangent of that, 10.9 over 0.75. And so the angle here ends up being 86 degrees, and it is going to be north of west. Okay, you also could have done 4 degrees west of north. That would also be an acceptable answer. We see here, though, these three steps are really key. So the first step, we are always componentizing our vectors, breaking them into x and y. In the second step, we're adding those components. And in the third step, we are putting those resultant components back together to get the magnitude, how big, and the direction, meaning the angle of our vector. Okay, we're going to go a little bit faster through this one, but the idea is the same. The first thing we're going to do is break this into our x and y components. So that's what that would look like for that first vector. The second vector we don't actually need to break into components because there is no angle. So for the first vector, our two components are going to be, the x is going to be 9 cosine of 35. The y is going to be 9 sine of 35. So we're going to find that my x component is 7.37 meters per second. The y component is 5.16 meters per second. All right, so there are my components. We could talk about the components of this one. The x component is simply 0 because it's not moving at all in the x direction, and the y component is simply 10. So we can still break it into components, but we don't need to use any trig. Next thing we're going to do is we are going to add the components. So in the x direction, we have 7.37 plus 0. So we get an overall of 7.37 meters per second, and it's positive, so going to the right. And in the y direction, we have negative 5.16 because that y component here is going down, plus our 10. So we end up with a resultant of 4.84 meters per second, and that is a positive. The final step here, we're going to take these components and put it back together. So I'm going to draw my x first, although you can draw your y first. And from the end of that x, I'm going to draw my y, the 4.84 going up. We have that tip to tail here. And so there's my resultant. So in order to get the magnitude, I need to Pythagorize this. 4.84 squared plus 7.37 squared equals c squared. So I get a hypotenuse here of 8.82 meters per second. For my angle, I'm going to say that tangent of theta is opposite, 4.84 over adjacent. 7.37. So the angle is the inverse tangent of that, 4.84 over 7.37. And so my angle here becomes 33.3 degrees north of east. Okay, alternatively, I could have said 56.7 degrees east of north. Either one is acceptable. For my last one here, I'm going to start once again by componentizing my vectors. Okay. And so I have the x and the y here, x and the y here. For this first one, the x is going to be 8.485 sine of 30 because it's the opposite side. So I get a value there of 4.24 newtons in this case. Again, a unit we haven't used yet, but it really doesn't matter what the units are. The vector addition is the same. In the y, we have 8.485 cosine because it's the adjacent side. And so we find that that becomes 7.35 newtons. All right. On the other side, we have my x is going to be 6 cosine 45. And so I get an x of 4.24 newtons. And my y is going to be 6 sine of 45 because it's the opposite. And so I get a y value also of 4.24 newtons because that's what happens when our angle is 45 degrees. So I've done my first step here in componentizing them. My next step is I'm going to add the vectors together. So in the x, I'm going to have a negative 4.24 because this one is going to the left, plus a positive 4.24 because this one is going to the right. And so my x component actually ends up being 0. And in the y, I have a negative 7.35 plus another negative 4.24 because this component is also going down. So I end up getting negative 11.59 newtons. So when I go to put these vectors together, it's actually quite easy since I don't have an x. I simply have my y component, 11.59 newtons. That is my magnitude, and the direction we can just say is south, no angle needed. So there's my answer, 11.59 newtons south. Alright, so we're going to move on to some vector subtraction, which we're going to do basically the same way. We're still going to start by finding our components. Okay, so I'm going to draw the components of vector A and vector B. We're going to go ahead and find the x and y components of each. So for A, the x component is going to be 5 sine 22 because it's the opposite side. So that x component is going to be 1.87 meters. And the y component is going to be 5 cosine 22 because it's the adjacent side. So that y component is going to be 4.64 meters. Moving on over to vector B, the x side is going to be 7 sine of 34, once again, because it's the opposite side. So we get that that x component is 3.91 meters. And the y is going to be 7 cosine 34. So we get that that component is going to be 5.80 meters. Okay, so now that we have our x and y components found, we're going to go ahead and subtract them now. So in the x direction, we're going to have negative 1.87 minus 3.91. And so we end up getting negative 5.78 meters. Okay, and in the y direction, we have negative 4.64 because it's going down, minus negative 5.80. We're subtracting that 5.80, and that 5.80 is going down, so we really end up adding the two. And we get 1.16 meters, positive 1.16 meters. So the only thing left to do now is to put these two vectors together. And so when we do that, we have our 5.78 meters in the x direction, and we have our 1.16 meters in the y direction. So there's our resultant, and we can go ahead and Pythagorize this to get the value of the hypotenuse. So a squared plus b squared equals c squared. So we have 1.16 squared plus 5.78 squared equals c squared. And so we get here that c is going to be equal to 5.9 meters, so that's my magnitude. And the angle, I'm going to say tangent of theta is opposite 1.16 over adjacent 5.78. And so I get that the angle is the inverse tangent of that. And so for my angle, I get an answer of 11.4 degrees, and that would be north of west. I also could get the reverse of that, so 78.6 degrees west of north. Either one would be acceptable there. Last subtraction problem here, I'm subtracting these two vectors, so start with finding my components once again. X and y for each, so this x component is going to be 4 cosine 15. So I get that the x component is equal to 3.86 newtons, okay? And the y component is going to be 4 sine of 15, so I get that the y component is equal to 1.04 newtons. Okay, moving on to the other vector, b, the x component is going to be 5 cosine 40. So I get that that's equal to 3.83 newtons. And the y component is going to be 5 sine of 40. So I get that that component is equal to 3.1 newtons. Now I'm going to go ahead and combine my components. So in the x direction, we're going to have negative 3.86 because it's going to the left, minus 3.83, and I get 7.69 newtons, negative 7.69 because it's going to the left. And then in the y, I have 1.04 minus 3.21, and so I get that in the y we have negative 2.17 newtons. Okay, so now I'm going to go ahead and put these together. So I have my x component, the 7.69 newtons, going to the left. The y component, the 2.17 newtons, going down. So my resultant looks something like that. I'm going to Pythagorize this. A squared plus b squared equals c squared. So I have 7.69 squared plus 2.17 squared equals c squared. And so I get that c is equal to 8, when you round it, 7.99 meters. And then for the angle, I'm going to say tangent of theta is equal to opposite 2.17 over adjacent 7.69. And so I find that my angle is the inverse tangent of 2.17 over 7.69, which gives me an angle of 15.8 degrees, and that's going to be south of west. Or, as always, I could also say 74.2 degrees west of south would also be acceptable.